So we have, I think one group is saying that it's the y-intercept, most are saying that it's the slope. How do we know that it's not the y-intercept part? First of all, I can tell it's not the y-intercept part.
It's around the 1.
Right, it goes through the point at x equals 1. If it crosses the point at x equals 1, it's not the y minus 1. This is bad news. Bad news, because it means that you messed up somewhere on the derivative, right? So you have to go back to where you took the derivative to actually figure out what's wrong. How do I know it's the slope? I know it's not the y-intercept, so I could use process of elimination, but it's that's harder to do, actually. How do I know? I can actually look at it right away and say, they screwed up the derivative. Minus 5. How do I know that? Just by looking at it.
The line's in the wrong direction.
Line's in the wrong direction. So we know what this tangent line looks like. The curve, and that has to be 1. So the line would have to be like this. It's going in the opposite direction. Most likely that tells me not only that I made the mistake in the derivative, that I probably made what kind of error in the derivative? Probably sign error, because lines that lean this way have positive slope, and lines that lean the other way have negative slope. So I probably have a minus sign error. It even tells me where to go look. And you know, when you're taking a quiz, it's really hard to think like that. But when I am taking any quiz these days, or doing anything, I assume I'm wrong all the time. And then I go from there. I become a good huntress at finding my mistakes. Okay, the last one. Many of you said over and over to me that the line, the curve, the tangent lines have to touch the curve in one spot. I think I told you that the tangent line has to touch in that spot, but I never said it has to touch only in one spot. So I was kind of curious why two sections had internalized that it should only touch in one spot. So I had a wonderful professor. I mean, I thought he was wonderful. I don't think he thought I was that wonderful, but I had him for a class, and I thought he was a genius. You know, when you go to your next college, you go to the next place you go to, you're going to find real heroes. You'll think that the people you meet here are heroes, and then you'll meet a new breed of heroes. This guy was amazing. Would walk into a class, start writing on the board without any notes, theorem, proof, and wow, this guy was a genius. So I asked him if I could do what's called an independent study with him in the following year. Independent studies mean that it's one-on-one. And what he wanted me to do was to come in and read and present to him. So I would stay up, reading, making sure I had perfect notes, come in and explain things to him. He'd fall asleep. It's just me and him. So I'm lecturing to someone who's completely asleep. And every once in a while he'd wake up. And I'd say, do you have an example for that? And I usually would say, no, I don't. Because I think as an undergrad, we're used to the professor giving us the examples. And so when he was asking me to do that, I found that a very weird question. So the next time I thought of examples for everything. I came in all ready. He did the same thing. Fell asleep. Woke up, asked me for example. You know, it's funny you asked me that. Do you have an example for that? And he said, okay. What if I change something here? Now, do you have an example for it? No. No, I don't. So you learn so much. That professor taught me in that one independent study, sleeping or not sleeping, so much because I had to develop my own understanding. And so I'm asking you to do the same. Now make a curve that crosses in more than one point of the curve, but it's the tangent line at x equals minus 1. And that's what you're going to have to turn in as the in-class assignment for today. I'll blow it up more because it's yellow. It's probably very hard to read.
No.